जी, राइट साइड में जो ये विद्यार्थी है उसके पास आप दीजिए, उसके बाद संस्कार स्कूल के विद्यार्थी को तैयार रहना है।
Good morning everyone. Good morning sir. Myself Navya Bhora. I'm in grade 17 and I study in MGM Cloverdale School. Sir, as you have designed ice stupa, undoubtedly it saves a lot of water. So my question is, can you describe this science behind the ice stupa and how it faces the scarcity of water in Ladakh?
Thank you. Can you hear me?
Yes.
Okay. Ice stupas or artificial glaciers are a very interesting mix of science and mathematics, and therefore developed by students while studying their maths and science to solve the problem of water crisis. Now Ladakh, which is in the Trans-Himalayas, which means it is a desert. You think of Himalayas and you think of Kashmir or Himachal. Nothing like that. When you cross the Himalayas and come to our side of the Himalayas, it is Rajasthan, only at 11,000 feet. Okay? So, God has left us high and dry. Literally, in the English phrase, to leave someone high and dry, that was meant for us. So we are high and dry up there. There's hardly any water dripping from the skies. You have so much, sometimes too much. We have hardly any. But what we get is a little bit of snow. Little bit of snow in the winter. But snow being snow, solid rather than liquid, it collects over years and dozens of years, and then it becomes a glacier. So first of all, we should know what is a glacier, to know what is an artificial glacier, ice stupa. So glaciers are what feeds us. Collection of snow from tens or hundreds of years that melt and trickle and come down to us. What you get is rain. The problem with rain is that it cannot be stored. It will just flow down into the ocean the same day or month. Good thing with snow is it can stay there for hundreds of years. So that's what it is, but the sad thing is that thanks to the kind of development we are seeing, the temperature of the earth is rising, and even those stores of snow, which are called glaciers, are melting very fast and it will be gone soon. So what we are trying to do, initiated by a very elderly Ladakhi innovator, who started some work on refreezing that melting glaciers in winter when nobody needs water. When nobody needs water, it goes into the ocean. So how do you keep it longer? The idea is to freeze it. Freeze it where it is or higher than your village, and then in spring it will flow down. So that's the idea. But there were some problems, like when ice is flat, horizontal, the sun melts it prematurely. Before you need, it's all gone. So in our school, together with the students, we were saying, Mr. Nordfeld, who was doing this artificial glacier, he has a problem. And the problem is that it melts too early. How do we prolong it? Some of us came up with the idea that actually it's the sun that is melting, and sun needs surface area to work. In Ladakh, every meter square has roughly 1 kilowatt of power of the sun. So ice melts so quickly. So how do you reduce the surface area and still keep the volume? Because sun needs area, farmers need volume. They don't care about area of water. They need volume of water. Sun doesn't care about volume of water. It needs area, surface area. So how do we play a trick with the sun? Not give it area, but give the farmers volume. Then you connect to what you learned earlier, that in geometry there are certain shapes that have low surface area and high volume. Do you remember any? What shapes? Spherical is the first answer. Sphere is the most efficient shape for surface area and volume. Sphere has the minimum surface area for the given volume. That's why drops take that shape. Okay. That's why so many other things are made spherical. So it's cheapest to build and most volume. Now sphere will be not very practical. How do you build a sphere of ice? Hemisphere is still easier. Hemisphere, because it's flat on the bottom. And even a cone will do. Not as efficient as a sphere or hemisphere, but cone, because cones are easy to make. So if you put anything, just take sand and let it drop, it will make a cone on its own. You take atta and let it drop slowly out. Salt from the salt holder, it will make a cone. Similarly, ice, you can make a cone. But easier said than done. How do you make an ice cone of 5 stories, 10 stories? No? It's like a pyramid. And pyramids are not easy to build. You can ask the Egyptians. So how can you trick nature? It's all about tricking nature. And make it do the work and still get an ice cone. Good thing with water, unlike poor Egyptians who had to carry rocks, good thing with water is that when it is in liquid form, it follows hydrology. It can be pressured to go up. And it goes up, like with a pump. With a pump, you can send it. You don't have to carry. You can just switch on and send it up 5 stories. But the bad thing is that we don't have that switch nor the power in the mountains. Right? No power. So where will you run a pump to take water to 10 stories and then make it freeze? The good thing in mountains is that you have gradient. Gradient means gravity. Upstream, downstream. And the good thing in primary school science is that you say water always maintains its level. So if you put a pipe upstream, 15 stories higher in head in the valley, then there will be pressure in the pipe. The water will want to keep its level. It will want to go to 15 stories. So there will be pressure in the pipe for it to go back to that height, even if it is downstream. And that is energy, gravitational energy. If you put a fountain there, it will spray water like there is a pump. Without a pump, just a pipe, you get a pump free of cost thanks to gradient, which you don't have in Aurangabad. You have so many other good things. We are not jealous. So you don't be jealous when I say pumps work without bijli, without pump in Ladakh. Because we have gradients. So we should be happy. No jealousy on your part there. So we just put a pipe upstream and it works like a pump, a big pump. Normally it would take an engine like a truck, the size of a truck to do what we do, but we do it free with just a little pipe. So what does that do? That sprays the water into the -20 air, where that cold takes away the heat from the water at 10-story tall, and that heat, if you remember your physics in 9th and 10th grade, that heat which keeps a liquid, without that it becomes solid or frozen, is called latent heat. You check your 9th and 10th grade physics. Latent heat is that. So when you spray water in -20 air, the latent heat is extracted mid-air. So it rises up as liquid water. We trick it to go by itself up there, not like Egyptians, more clever. And then when it falls as solid ice. And like other things, it takes the shape of a cone. And that cone has minimum surface area for the volume. The work is done. That's ice paper.
So nice, sir. Thank you so much.
You should look up some videos on YouTube if you say ice paper. I'm sorry. In this much of time, I could explain so much and already I've taken too much time. And that cone melts in summer and gives off.
Yes, you should. Next question. संस्कार विद्यालय कोई पूछना चाहेगा? Yes.
Hello sir, good afternoon. My name is Sonam Wangchuk. I am student of Sanskar Vidyalaya. I have one question, and my question is, what challenges did you face while implementing your sustainable inventions, and how did you overcome them?
Okay, thank you. I didn't face challenges, and I didn't overcome the challenges when I faced them. All this sounds crazy, no? Didn't face challenges? What this guy is talking about? And didn't overcome them when you face. I try to overcome the challenges before they come. Yeah? What does that mean? What does that mean? That means that you prepare yourself mentally to have huge challenges. Then whatever challenge comes looks very small. Okay, if you prepare your mind to see no challenges, only roses, then one thorn looks such a big challenge, you start crying. But you think thorns and thorns and thorns, and then there are no thorns, very happy. Rose, one rose, very, very happy. Two roses, even more happy. So you will be more happy if you already expect, overcome the challenge before you meet the challenge. What is happiness? Happiness, actually happiness is so relative. It's relative to our expectations. If our expectations are big, then it is very hard to be happy, because happiness, mathematically speaking, happiness is equal to expectation minus reality. If expectation is small, reality is reality minus expectation. If reality is not very big but expectation was so small, you are happy. The reality can be small to big, but if your expectation is even smaller, then you will always be happy and your challenges will be much smaller. That's the overall outlook to life. But of course, when you face challenges, you do have problems. But if you have already expected them, they are smaller than anybody else would feel.
Thank you.
People ask me, how did you stay hungry for 21 days? Because I expected to stay for 30 days. So 21 days was nothing.
So nice, sir. Thank you so much. Anyone from junior college, Sanskar Junior College, you want to ask? Please.
Namaskar sir, myself Amrita Chauhan. I'm from junior college. My question is, how do you get project ideas, visualize them and bring them into existence? Do you feel it's purely your hard work, or do you feel it's some unknown energies plays role?
Well, I don't look for ideas. I only try to solve what is actually a serious problem. It's not good to look for a problem to solve. It's good to solve a problem that's a huge problem for some people. So it should be driven by empathy, karuna, for people facing problems, rather than I want to solve a problem and I want to become a famous problem solver or innovator. It should start with a problem that you genuinely feel pain for. That's the best way to start. What was your second question?
Do you believe it's purely your hard work, or do you unknown energies also play roles?
No, known energies play roles, and the known energies are all my team members.
So we have so many engineering students present over here. They also want to ask you some questions. Anyone from Genesee?